Hello friends. In this video, we are going to study the programming model of the ARM processor. With programming model, we refer to the registers which are used while we are programming or writing the instructions in the processor. So here we will study the programming model of the ARM processor. So let us start with our topic. So as I've said that by the programming model we mean that when we are doing the programming over the processor, then which of the registers are being used, which of the components of the processor they are being used while doing the programming. Okay, so the internal structure or internal registers which are used during the programming of the processor, they constitutes the programming model. Now this ARM processor, it can operate in so the programming modes of the ARM processor, there are 7 programming modes. So according to these modes, the registers of the processors will be used. Okay. So we can say that the current mode of the processor, the mode in which the processor is being currently working, that mode is going to decide that which of the registers will be available to the user for the programming. Okay. So current mode is going to decide the availability of the registers to the programmer or the user. Now in general, the ARM processor, it has 37 32-bit registers. So in a general way, if we say that there are 32-bit registers in the ARM processor. Out of these 37 registers, there are total 37 registers. One register is called the program counter. Okay, one of the register is called the program status register. Okay, it is called the current program status register. Other is called the saved program status register. Okay, so out of the 37, one will be program counter, and one will be the current program status register, one is the saved program status register, and rest of them will be the 30 general purpose registers. And all these registers are the 32-bit registers. Okay. Now these registers, they are arranged in several banks. Okay. And these registers will be accessed by the programmer according to the processor mode. Okay, so whatever will be the current mode of the processor, according to that mode, these registers will be available. These registers can be accessed by the programmer. Now, if we talk about the modes of the processor, then each processor mode, it can access the R0 to R12 register. So each processor mode can access R0 to R12 registers. So R0 to R12 will be the general purpose registers. Then we have the R13. This is the stack pointer. Then we are having R14, which is the link register. Then we are having R15, which is the program counter. Okay. Then we are having two other registers called the CPSR, that is current program status register, and saved program status register. CPSR and SPSR. So in total, the processor, it can access the R0 to R12. R13 will be stack pointer, R14 will be link register, R15 will be program counter, and two other registers will be present called the CPSR and the SPSR. Okay, this is common in all the processor modes. Now, if we divide or classify the modes of the processor, then these modes are of two types: privileged modes and non-privileged modes. Now, these privileged modes, they can access the SPSR. But the non-privileged modes, they cannot access the SPSR. So in those modes, SPSR is not present. Okay, so this is in generalized way. We have seen that there are 37 total registers. Out of those 37, there will be 30 general purpose registers, one program counter is there, one current program status register CPSR, and one SPSR will be present. And in a generalized way, if we see, R0 to R12 will be the registers, R13 will be stack pointer, R14 will be link register, and R15 will be the program counter. Now let's see the programming model of the ARM processor. So you can see that these are the different modes of the ARM processor: user 32, FIQ 32, supervisor, abort, IRQ, and undefined. These are some of the modes of the ARM processor. Now each of these modes, the function of the registers will be different. Okay. Here we have shown the 16 registers from R0 to R15. Now out of these 16 registers, the 13 registers from R0 to R12, as I have said earlier that from R0 to R12, these are the simple registers. So R0 to R12, they are the simple register. R13 is the stack pointer, R14 is the link register, and R15 is the program counter. Now the SPCR and the CPCR, these are the two other registers, but in the non-privileged mode the SPSR is not accessed. So user 32, it is a non-privileged mode. In that mode SPSR is not present, only CPSR is there. In the remaining modes the two registers are present. Okay. Now the function of these register will depend upon according to the current mode of the processor. Suppose that the current mode is user 32, so in that the function of these registers is defined as here, like R0 to R12 will be general registers, R13, 14, 15 they will be stack pointer, link register, and program counter. Now their functions will be changed when the processor mode is different. Like in FIQ 32, R0 to R7 will be the general purpose registers, R8 to R13 these will be the banked registers, and up till R14, then R15 is the program counter. Okay, so depending upon the mode the function of these registers is different. Let us first study this first mode, user 32. In this mode some of the registers are the general purpose registers. In every mode there will be some registers which are called the general purpose registers. Now what is the function of these registers? They are used to store the data or addresses, or we can say they are for the holding the data and addresses, to store them. Okay. So depending upon their purpose for which they are used, we are having R0 to R12, which are the general purpose registers. Okay. Then according to the mode, we can use these R13, R14 and 15 also as the general purpose registers. Depending on the purpose, R13 to R15 can also be used as the general purpose registers. Okay. Now next is the R13, which is the stack pointer. Now the function of the stack pointer is to store the address of the top of the stack, the memory address from where the stack is starting, the beginning address that is stored in the stack pointer. So here stack pointer stores the top of stack. So in this user mode, user 32, the R13 register is used as the stack pointer. Now according to the modes the register will be changed. Okay, like in this FIQ 32 there is no stack pointer. Okay, so according to the current processor mode the stack pointer is going to store the top of the stack. Next register was R14, that is the link register. Denoted as LR. Now this link register is used to store the temporary address, like when we are having the subroutines or the interrupts, then where it has to jump to that memory location, that address is being stored in the link register, and where it has to come back. So to store the temporary addresses between the operations, the link register is being used. So it is used for storing the return address in case of subroutine. Okay. Next is the R15. R15 is the program counter. Program counter, it's denoted as PC, and it is used to store the address of the next instruction, where the next instruction is being written. So that the processor will get to know that where the next instruction is written in the memory, because the address of that next instruction is stored in the program counter. Okay. Now, this was the description of the registers in the first mode, that is the user 32 mode, okay, which is the non-privileged mode. Now, in the privileged modes, the function of the registers will be changed. Let's see the FIQ 32 mode. Okay, now in this mode we are having the registers R0 to R7. These registers are called the general purpose registers. Also, these registers are called the unbanked registers. Unbanked registers means that these registers can be used as the general purpose registers. General purpose registers, they are always used for holding the data or the addresses. So just like that, the R0 to R7 registers can also be used. And each register, we know it is a 32-bit register. Okay. So in this, you can see that R0 to R7, these are the unbanked register. Now there are some register which are called the banked registers. Banked registers are here R8, R9, R10, 11, 12, 13, 14. These are the banked registers. In the supervisor mode, we are having R13, R14. Here also R13, 14, 13, 14, and 13 and 14. Here SPSR, SPSR, these are all the banked registers. So there are unbanked also and banked registers also. Okay. So here you can see that bank registers, they are shown by the sign, the register number, then underscore, and after that we are written the mode. Here also R13 and 14, after that the mode is written. So after all the bank registers, they are shown as the register number underscore the processor mode. Okay. So we can say that the registers R8 to R14, they are called the bank registers. Why they are called the bank registers? Because the physical size of these registers is decided by the current processor mode. in this unbanked register, size is fixed, that they are 32-bit registers, but banked registers, their size is decided by the current processor mode. Okay, these registers can be used as the general purpose registers also, depending upon the processor mode. You can see that in the supervisor, abort, IRQ modes, they are being, some of the registers are used as the general purpose registers, whereas in FIQ, R8 to R14, these are used as the banked register. So depending upon the processor mode, the function of the registers is changing. Okay, now, so we have seen in this mode, in this programming model, that we are, in a generalized way, we are having the 30 general purpose registers, then we are having program counter, stack pointer, and current program status register, and saved program status register. Okay, and we have seen the function of these registers also. Okay, now here in this FIQ 32, this mode, R15 is used as the program counter. In the supervisor mode, again the R15 is being used as the program counter. Here also, okay, so function of R15 register is specific, it will be used as the program counter. Now let's see about the link register. This link register, it has two specific functions. There are two functions of this register. In each processor mode, this R14 is used to hold the subroutine return address. Okay, and also it is used in case of exceptions, that is interrupts. So in case of interrupts also, it is used to hold the return address. So this link register, it holds the return address, one for the subroutine and other for the exceptions and the interrupts. Because whenever the interrupts are being given to the processor, so it has to jump to some other memory location where the interrupt service routine is being written, and that subroutine will be executed. After that, it has to come back to the current program. So in all those cases, subroutine calls, and in the case of the exception interrupts, this link register, it is used to hold the address, or hold the return address, so that the processor can return back to the main program. Okay, so this was the programming model. We have seen that in this programming model, we have seen that there are 37 registers. Out of them, we have seen the functions of the general purpose registers and the other stack pointer, program counter, link register, CPSR and SPSR registers. And we have seen that how the function of these registers is differing in the different modes of the processor. So according to the current processor mode, the function of each of the registers will be defined. Okay, so I hope that this topic, ARM processor programming model, is now clear to you. Thank you.